So if you're tuning in, congratulations, you've now made it to the second part of chapter 1. With this section, we'll be dealing with basics of functions and their graphs. Like it says here, basics. So a lot of this stuff is going to come back again. Some of this you might have seen before. Definitely from Algebra 2, domain and range should sound familiar. If you were with me for Algebra 2, you might remember this guy here, Dr. XY, which was a convenient way in my eyes to remember which domain and range correlated with as far as x values and y values. The domain correlates with what x values you're using. The range correlates with the y values you're using. So that's a quick little refresher. We'll be determining if a relation is a function or not, determining whether an equation represents a function and why that might occur. We'll be evaluating functions, plugging in select numbers, but maybe also binomials, graphing functions by plotting points. Well, that's kind of what we did in 1.1, so that's good. Coming back again. Using the vertical line test to identify functions, obtaining information about a function from its graph. That also sounds like some 1.1 type material. Continuing to identify the domain and range of a function, identifying intercepts from a function's graph. That's also 1.1. So although there are a lot of objectives for this section, a lot of this we've done before. So let's get to it. With this first example, they have us plugging in this term here where x is adding on 2, and we're being given this equation seen here, this negative x squared plus 2x plus 5. So what this is saying is that this is the normal equation. So this is the normal equation. This is as is. This is something we could graph if we wanted to by plugging in points. But now they're asking us to evaluate this function. So this is tying into the fourth objective. So it's pretty much saying that wherever x is in this equation, we see an x here and here. Instead of x, we now want to put in x plus 2. And this can be a little tricky because we want to use parentheses on this one. You might be asking yourself, why? I'm smart. I think I'd just add on a 2 into here and here. This is a little bit different because now this is considered a binomial with 2 terms. So if we rewrite this using parentheses for that first x, also for the second x, we're adding on 2 versions of parentheses, x plus 2, and parentheses, and we're adding on 5. So there's a lot going on here, but again, it's nothing we can't handle because what we have here is algebra 2. This is eventually going to be combining like terms and then just adding on 5 at the end. So I know that I'm going to have to deduct this product here. I think it's easier to just kind of focus on this one step at a time. So I know that if it's x plus 2 being squared, if you need to take this aside and need the refresher from algebra, this is the box method, which is going to help us evaluate this binomial being squared. In each of these terms, we're taking a product. So I have x times x, which is x squared, 2 times x, 2x, 2 times x once more, 2 times 2, which is positive 4. So if I combine these like terms through the middle, this will get me x squared plus 4x plus 4. So this is now what I want to write in here versus this setup. So I'm now rewriting, still subtracting, so keep that in mind. X squared plus 4x plus 4. We'll jump ahead and start to simplify these terms. So distributing 2 to x and 2 to 2. We're now adding on 2x plus 2 times 2, which is 4. Adding on 5. So the tricky part here in my eyes is to remember that, one, you have this little subtraction sign here. And I'm going to put a little smiley face next to this because it's something that I want to highlight on and keep in mind about, but don't let it throw you off. Just be consistent with rewriting the equation. So I'm subtracting all of this. So it's as if I'm going to take each of these three terms in this trinomial and just make them negative. So we're subtracting x squared, subtracting 4x, subtracting 4, continuing to write the rest of this equation, adding 2x, adding 4, adding 5. You might notice that there are a lot of terms here. If you want to color coordinate, go for it. So I know that I have just one x squared term. I have two x terms. And finally, I have three constants. So negative x squared is leading the pack. We're just subtracting that. Negative 4x, and we're adding 2x, gets us negative 2x. Getting us to negative 4 plus 4 plus 5. Well, these 4's cancel each other because we have a negative 4 and we're adding 4. We're just adding on 5 towards the end. There are no other terms we can combine, so this means that we're done. Leaving us this final answer here of negative x squared minus 2x plus 5. And this is equal to f of x plus 2. So lots of steps on this one, but take your time. If you get stuck, think about what we did here. We acknowledged what we were plugging in. We used parentheses. We took our time evaluating and distributing and also multiplying binomials, eventually getting us negative x squared minus 2x plus 5. This part towards the bottom can get a little complex. We're taking now what they call the composition of functions, where we now have more than one function that's being introduced. So it's kind of as if we're separating this problem from what we've seen previously. We're being given two new setups seen here. We'll fold this so we have a little bit more space. So this is saying that we want to try and evaluate f of g of 2. So I'll write out how this is stated. F of g of 2. And this may look intimidating because we have parentheses, we have two equations. This definitely has a lot going on, but I try to work on these from the middle outwards. So if we kind of block off the outer parentheses, hopefully in the middle we just see g of 2. That's all I see if I block out everything else that's going on. And g of 2 is something we can evaluate because we have this equation here. So if we have g of 2, this is equal to 2, which is staying as is, multiplying with x, where x is now 2, and we're then deducting 6. So with arithmetic, you hopefully shouldn't need a calculator for this. 2 times 2 is 4. Continuing to deduct 6 gets us negative 2. And keeping in mind this was another way for us to write g of 2. So again, I'll make a note on this on the side. I'm working from the middle, then outwards. And this was how I was reading off this equation. So I'm not quite done yet. I have g of 2, which is what I needed. And now I need to kind of reevaluate the larger picture because this did have f on the outside. So if I go and try to rewrite f of g of 2, g of 2 we just said was negative 2 when evaluated, so I can think of this now as f of negative 2, which shouldn't be too crazy to get a hold of because we have f of x, which is an equation. We know that x is going to be substituted in now for negative 2, so now it's a matter of just plug and chug. So we know if x is negative 2, we're then squaring it. We're adding on 3 versions of x. We're then deducting 2. So taking this from left to right, negative 2 when squared gets us positive 4. We're adding on the product of 3 and negative 2. So we're deducting 6. We're then deducting 2. Left to right, 4 minus 6 minus 2 is negative 4. And this is, again, f composed with g of 2. We'll soon see in the next video that we'll work with graphing some equations and seeing what the domain consists of, seeing what the range consists of, but being able to evaluate what x values are and equations in this format is definitely crucial for this. So again, as you move forward, remember to move from the middle then outwards as far as what equation you're evaluating, and always be on the lookout when you're combining like terms.